A very good day to the panels. My name is Nagalingeshwaran. Today I am going to present on my final year project 1, and my project title will be eHealth Yoga Mat using a Raspberry Pi. So let's start with my project background. As we know, health is something important in every human's life, where we have to take care of our health for a longer life and also to do our work and our daily routine in a proper way where it also affects health means which affects our physical as well as our mental. And this healthy lifestyle starts from our daily routine, such as food that we consume, our daily sleeping durations. As an example, we have to get at least 8 hours sleep per day to keep our mind and body fit, and doing exercises, walking for miles and daily, and our water intake level, and many more. So this health becomes a very major part in every human's life, but sometimes we tend to overwork, or we are concentrating in our work job, or if a student will be concentrating more on studies and so on. Sometimes we tend to forget take care of our health. In that case, we always need an assistant or guidance to take care of our health or reminders so that we can keep our physical and mental fit enough to run our daily routine. In that way, this e-health mat have three different features. And here I've mentioned that this e-health mat is connected with our phone application, where we can control it with our phone application. As a main controller, there will be a Raspberry Pi, and this eMat's main function is starting from the morning until night. It will be very much helpful for us. And the first function will be waking up alarm, where this alarm as our phone's alarm, but in phone's alarm, when we wanna off, or most of us will snooze it for a longer time sleep, but that's not an effective way. This mat going to be more effective, where you have the only way to stop the alarm is to waking up from the bed and standing on the carpet to stop the alarm, where it will activate your brain cells on the time when you wake up from the bed. Second, this mat will always keep data of your body weight whenever you are standing on the point, where this application will keep your daily data and progress of your body weight. And thirdly, the function will be assisting us by providing yoga postures, where it's going to keep our mental health and physical health fit enough and for a better future. So what is the problem statement? The problem statement will be interaction between human and physical devices in the real world is gaining more attention. As we know, technologies are improving day by day, and this e-health yoga mat is more into this technological based. And second, we need a right assistant to get a proper benefit from the way we execute to maintain our body health, because most of us sometimes we follow YouTube from Facebook videos, Instagram videos, TikTok videos, and many more, but we need a proper guide. Sometimes when we refer videos, we tend to do mistakes, and we need a proper assistant so that we will do it in a correct way to get our body in a more healthy manner. And without a proper guide or motivation in the morning, most of us can't wake up. So most of us, even we will snooze it when we keep alarm, as from my personal experience. So in that case, to overcome this problem, snoozing problem, I've created this alarm where you have to really wake up and stand on the mat to stop the alarm. Okay, this will be my objective. There are three objectives. So the main objective will be to develop an e-health yoga mat using Raspberry Pi, to integrate a project with yoga mat using which assists user on yoga postures by using FSR sensor, force sensitive resistor sensor, and also to evaluate the performance of yoga mat in terms of yoga posture. Scope of study. The scope of project is limited to electrical components and miniature prototype for a health yoga mat. And second will be the FSR sensor is used in the yoga mat to detect the movement of the user while performing yoga postures on the mat, and there will be also LED light which guides the user to put their hands and legs on the proper position to perform the yoga postures. Third will be Raspberry Pi 4 model B2GB will be used as a main controller to guide the yoga posture on the mat with the help of FSR sensor, and it contains a faster processor and RAM for a better performance. And this yoga mat size will be 24 inches wide and 72 inches long. So this is the basic block diagram. So as we can see, this yoga mat is connected with this Raspberry Pi, and this mobile application can go through this connected with this Raspberry Pi wirelessly, where we are connected with Wi-Fi. So the first function, as I've mentioned earlier, will be yoga postures. So for these yoga postures, there'll be FSR sensor, array sensor, and analog to digital converter sensor. And second input for the alarm clock will be 5 alarm setting key, 5 disabler. And for the weight detection will be HX711 load cell, amplifier, and spark fun load sensor combinator. And as an output, I'll be keeping a communication component where doing yoga postures, there will be a feedback if there's any wrong positions or on the mat when the user is using it, and there'll be a LED output as I mentioned earlier. And this main controller Raspberry Pi 4 will be controlled using a touchscreen LCD on the yoga mat itself, and there will be a groove speaker for the alarm system and also for a communication system. And finally there will be a hour indicator and minute indicator to show the time. Next will be project flow. So starting, there will be a project objective and scope analysis. Once done, I went into a literature review to do researches on other projects that related to my project eHealth Yoga Mat using Raspberry Pi, and from there I've created a methodology of my project flow, my project process, block diagrams, and many more. And from there it will be in 3 different parts where I'll be designing the circuit and mechanism, and second will be mechanical design, and third will be programming part using Python. And from there, if there's any malfunction or error, there'll be troubleshooting again. And finally, it will be an integration of entire project. A final testing will be done. Once device is working properly, that will be my final product for my PSM2. So process flowchart, this is the main process flowchart. So when I start, I'll be starting up the Raspberry Pi, and this Raspberry Pi there will be an application connected to my phone. So I will on this application, this Raspberry Pi, from my phone using Rasp controller, and once I turn on the Raspberry Pi, I'll authenticate my account. Once authenticate this account, the LCD display on this Raspberry Pi, and there will be this application, and this application will be in 3 different features. First feature will be yoga mode, second feature will be time, third feature will be weight scale. For the yoga mode, there's 2 modes. One is serene, which is a silent visual assist, where it will assist you just with postures, so you have to just follow the postures on the mat. Second will be active mode. In this active mode, it will be interactive, where there will be feedback when we are doing the positions on the yoga mat, and it will guide us how the posture should be. And there will be a LED blinks up on the movements on the mat itself, and the mat will read this movement with the pressure sensor, and it will give green light when we are giving the pressure on the right position, and it will be giving a red light if in case there's not enough pressure where we didn't put our leg or hand on the proper position on the mat. This for the yoga mode. Second, it will be for the time. For the time, as usual, we can set the alarm through our phone to the mat, but somehow we have to on the Raspberry Pi, so we have to set it on the Raspberry Pi itself, and we will set a ringtone. And once we set, the alarm will exactly ring on the time from the speaker, group speaker. And when we want to stop the alarm, we have to wake up and stand on the right position where the pressure can detect the user's weight, and the alarm will stop. Then the last one will be the weight scale, and this weight scale will be connected with the HX711 load cell and spark fun load sensor combinator, where when we are standing on the right circuit weight scale, it will read our weight and collect the data in our phone application or Raspberry Pi application. So we can refer our daily weight or in this routine from this data. And next one will be application flowchart. And this is how the application looks. We have to log in first. Once login, we have to select either we are a new user or an existing user. If in case we are a new user, we have to sign up and calibrate. Once calibrated, then we can start using the feature. And as I've said earlier, there will be three feature: yoga mode, time and weight scale. Under the yoga mode, there will be at home practice or dashboard. Under home practice, there will be two: serene mode and active mode. Serene mode is a silent visual assist. Active mode will be for a feedback communication mode assist. And there will be a dashboard, where in this dashboard we will keep our data of activity and the poses that are under in yoga, where we can go through some informations on this. Next will be for the time, in the time where we can set alarm, set time and set music as well. And third will be the weight scale, where we can read our weight and as it will be collecting our data when we are standing on the mat. So this is the basic alarm clock coding that I've done on the Python. So from this output, I've got a GUI form where we have to insert our time, and when we press the set alarm, the time will be running on the output. And when the output reaches the time setup, it will show a command of a wake up, wake up and wake up, and there will be a music on the background as well. So this is the basic circuit for now using Raspberry Pi 4 with an LCD, capacitor, buttons, transistor, buzzer, and also a load sensor. So next one will be for the weight scale coding. This weight scale coding, it actually reads our BMI as well, and it will give where does we stand, either severely underweight, perfect, overweight or obesity. So once run this coding, we have to insert our height and our weight, and once enter, it will show our BMI, where severe, underweight. This is for basic coding for now. When I'm doing this application, I'll be keeping this weight there. The height is not considered yet. The weight will be considered, and the weight will read the data and keep inside the Raspberry Pi. And finally, this will be my expected result, where it can detect user's body weight. The detected body weight will be saved as the data in this application. The alarm clock able to set up from the phone application itself. To stop the alarm clock, have to stand on the mat. The application will assist the user for yoga postures and movements, and LED light will be blinking to the user to make it easy to place the hands and legs to perform the posture on the mat. And finally, conclusion. As a conclusion, the objective and aim of this project will be achieved. During hardware development, this information on software management, circuit designing, component selections, and measurement reading has been improved. Theory related to the subject study has been applied in this project. Plenty of new technology and knowledge has been learned in developing this project, and this project gives a good knowledge and experience developing a project. So this is all from me. And finally, it will be a future work. A complete prototype needed to be built and must function properly for my PSM2. and an application will be built to control the function of alarm clock, yoga posture, and weight remotely from and our Android, the user's Android phone. And a circuit for weight scale, alarm clock, and application will be connected to the Raspberry Pi as it is the main controller for my project.